Okay, for these first three examples, these are going to go really quick. This is calculating the element's molar mass. That is if you just have one single element that you're trying to find. This is probably the easiest thing to do. Just look it up on your periodic table. This N stands for nitrogen. We're going to find nitrogen on the periodic table that has an atomic mass of 14.007. Au is the atomic symbol for gold, and that has an atomic mass of 196.967. Uranium is what U stands for, and that has an atomic mass of 238.029. And this is straight up just looking up the atomic mass. So let's go ahead and look at examples of calculating molecules' molar mass. Okay, to calculate the molecular molar mass of molecules and compounds such as CO2, H2O for water, and C6H12O6, which is glucose, all you do is you just add up all of the atomic masses of all the atoms of the elements that make up that particular molecule. So the first thing we're going to do is we're going to take a look at CO2. We'll take a look at carbon. Carbon has an atomic mass of 12.011. And there's only one carbon in it. So we're going to, just to show that this is what we are doing, we're going to multiply that by 1. Then we're going to take a look at oxygen. If we take a look at oxygen, it has an atomic mass of 15.999. I'm just going to write 16. To save some space on my whiteboard here. And there are 2 oxygen atoms. So what that means, we have to multiply this 16 times 2 because there are 2 oxygen atoms in this total CO2 molecule. Oxygen in the CO2 molecule. Okay, so we're going to do a little bit of work here, kind of show what's happening. 12.011 times 1, well, that just comes out to 12.011 plus 16 times 2 gets you 32, and then we'll just add those together. I'm going to try and do this mentally, so bear with me. 32, 2 plus 2 equals 4, plus 1 equals 4, so 44.011. Give or take a couple hundreds and thousands. That's one example. Let's go ahead and take a look at water. Okay. Water has 2 hydrogens and 1 oxygen in it. So the first thing we got to do is we got to take a look at what the atomic mass of hydrogen is. That is 1.008, and there are 2 of them. So we're going to put these in parentheses again. Multiply it by 2, and then there is an oxygen atom in here, so we're just going to leave this as just 1 oxygen atom, which has an atomic mass of 16, or very, very close to it. 1.008 times 2, I'm pretty sure I know what that is. Let me calculator it. 2.016, yep. Plus 16, and that comes out to 16, 17, 18.016, or very close to it. That is atomic mass units. We'll take a look at just one more example here, glucose. Glucose has 6 carbons, 12 hydrogens, and 6 oxygens in it. I'm going to push this up so that I have a little bit more room to work with. Okay, first thing we got to do, take a look at carbon. Carbon has an atomic mass of 12.011. And there are 6 of them there, so we're going to have to multiply that by 6. Hydrogen, there are 12 of them here. Hydrogen has an atomic mass of 1.008, so we'll go 1.008 times 12. Let me do this for continuity's sake. There we go. All right, and then there are 6 oxygens. So atomic mass of 16 times 6. Now I'll kind of break this down, simplify it really quick. There are 6 hydrogens here, so we will go 12.011 times 6, and that gets us 72. Plus, and that is going to be 12 something, 1.008 times 12. And then 16 times 6 is 96. And then this is going to come down to, well, we'll just add those together. So that plus that. And that comes out to 180.162, and that is in atomic mass units. That's all there is to it. This is probably one of these more easier things to do, if not maybe just slightly time-consuming things to do in chemistry. If you have a tool at your disposal that you can use, such as Google, I highly encourage you to just look it up unless you're being told to do this for a class of sorts. It's just so much easier to just go to Google. The entire database has it, and it's so much easier to just go, hey Google, and ask for it, or hey Siri, and ask for it, and then rather than just calculating all this mess. But in case you need to do it for whatever reason, this is how you do it. I hope you found this helpful, and I wish you luck in your future academics in chemistry. Leave a like, subscribe if you did find this helpful, and I'll see you all in the next one.